All right, let's take a look at another argument here and we will decide if it is valid. So we've got 7 plus 5 equals 12 or 8 minus 3 equals -2 as a premise. 7 plus 5 does not equal 12 as another premise. And the conclusion, thus or therefore, 8 minus 3 equals 2. Okay, so again, just as a reminder, we've got a premise, got another premise here, and then this is the conclusion. Okay, so first thing, write the argument in symbols. So identify the simple statements and assign variables. All right, so let's let statement P is going to be the statement 7 plus 5 equals 12. And let's let statement Q be 8 minus 3 equals 2. Okay, so what we're going to do is we're going to write the argument in symbols. So the first one, we have our 7 plus 5 equals 12. That's our P. Or, so we need our symbol for or, which is our little v. And then we've got our other statement there, 8 minus 3 equals 2, which we called Q. Okay. The next premise would be not P. Okay, we're saying those do not equal each other. And then, therefore, what have we concluded? Well, we have concluded that Q is the result, okay? And let's see if that is true. So next, write the argument as a conditional statement. So use a conjunction between the premises and the implication symbol for the conclusion. So what that means is that we want P or Q and not P implies, it's like an if-then, remember, Q, okay? And again, I'm using the parentheses for the P or Q, again, just to separate it out to make it very clear that that's the first premise. You don't necessarily have to, I just think it makes it clearer. All right, so then we set up our truth table. So I've started us out with the P and the Q. From here, we need to start filling in different parts of our argument. Okay, so I'm going to start with this first part here, the parentheses, the P or Q. Okay, so remember when we're evaluating P or Q, we're going to use the P and Q columns. And for an or to be true, we just need one, at least one, of P or Q to be true. Okay, as long as they're both not false, we have an or that is a true statement. So this would be true, 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 and we have a false, false, so that would be false. Okay, so there's the first step of that one. All right, the next part of the argument that I'm going to go ahead and pick up is this not P. Okay, not P. And so to evaluate the not P, we only need to use the P column. That's the only variable that's being used. And so we switch the truth values for a not. Okay. The next thing I'm going to go ahead and do is pick up the entire left-hand side of this statement. Okay, so now I'm going to have P or Q and not P. Pick up that part. Okay, so again, looking at what we've got, we want to do, let me erase my highlighting here. Okay, so our new highlighting would be to use my P or Q column and my not P column, and we are evaluating an and. So remember, the only time an and statement is true is if both of the statements themselves are true. So I've got a true and a false, which gives me a false. Again, a true and a false. A true and a true, that gives me true, and then a false and a true, which gives me false. Okay, the very last part then that we will do is now we will go ahead and do the entire argument because we've got all the bits and pieces we need. So we want our P or Q and not P implies Q. Okay, and again, from a standpoint of what we're looking at, okay, we're going to be using this column here that we just filled in, implies Q. So again, a little backwards. We're going to kind of work from right to left this time. All right, so going through, does false imply true? Okay, yes, it does. That's a true. Does false imply, like if we have false, does that imply false? Yes, that's a true. True implies true. Yes. False implies false. Yes. Okay, so again, we have a tautology. Okay, so the argument is a valid one. Okay, and this is a perfect example of what did we just conclude? Okay, and you might have lost sight of it, and actually that's a good thing, okay, because all we talked about was P's and Q's, but really, what did we just conclude? We said 8 minus 3 was 2. Again, this is not about whether or not the statements themselves are true, okay? This is about whether the argument that's being made even has validity. Because if the argument itself isn't valid, it doesn't matter whether the statements themselves are true or false, because the argument falls apart before you can even begin to make your claims, okay? So at this point, again, don't worry about whether or not you're like, but that's ridiculous, it's not true. We're not asking whether 8 minus 3 equals 2. We're asking whether or not the argument being made has validity.